Hey everybody, this video is going to be talking about adding the functional group alcohols to our hydrocarbon organic molecules. So up until this point, we've only learned about hydrocarbons. So we've only had hydrogen and carbon on our organic structures. Now things are about to get crazy, and we're going to add oxygen to the mix. So there's actually lots of ways oxygen can be added onto a hydrocarbon. And all these different ways we kind of refer to as functional groups. So a functional group is basically a group of new atoms involving other elements or elements we've already talked about that are already on the structure. And basically these functional groups are like the identifying feature of the molecule. They are incredibly important. So they're going to take precedence over anything else that we've talked about up until this point when it comes to naming. So the first one we're going to talk about is called an alcohol. An alcohol is defined as a hydroxyl group that comes off of a carbon chain. And it looks like this, OH. So it's basically an oxygen bonded to a hydrogen coming off of all the hydrocarbons that we've already talked about up until this point. You generally see it written as this, even though in all actuality, if we're actually going to draw this out, the oxygen is single bonded to the hydrogen. And also that oxygen also winds up with two lone pairs on it as well. And this oxygen-hydrogen group is always single bonded to a carbon. Now, that carbon could be like the carbon in the middle of a chain, it could be in the middle of a cyclo, it could be any kind of carbon we've already talked about. So we generally generalize that by writing in this letter R, kind of with it. So R stands for any hydrocarbon structure we've already talked about. And then that oxygen is single bonded to that carbon, which is also single bonded to the hydrogen with two lone pairs. So this is your actual structure. But like I said, we generally simplify it by just writing this OH down instead. So what you're going to need to be comfortable doing is essentially naming and drawing compounds with an alcohol on them. And part of that is just recognizing alcohols. The reason that we are talking about alcohol specifically is because when we get into our food chemistry unit, a lot of the food molecules we're going to be talking about have alcohols on them. So this is a common structure that pops up on a lot of different everyday household products. So here's the big thing. Okay, so all the stuff that we learned previously, okay, with hydrocarbons and isomers and branches and all that good stuff. Basically, here's the only new thing. You need to add the ending anol if you see an alcohol on the structure. So if you see an OH on the structure, you are going to put anol on the ending of the name. Otherwise, everything we've learned up until this point stands. So for example, let's try a couple. If I drew this, for example, okay, you would see one carbon, so you would say meth, because that's our carbon prefix for one carbon. And then you now see the OH, which is our alcohol functional group. And whenever we have an alcohol, we add anol. So you're going to say meth, anol. Done. That's it. Easy. Boom. So let's try another one. If I drew this, all right, now you see two carbons. So now you would say F, because that's our prefix for two carbons. You see the OH, that alcohol functional group again. So then you're going to say anol. If we do our counting, this alcohol, 1, 2, 1, 2, if you count backwards, is on the first carbon, so you don't need to add a number. So this is just called ethanol. All right, so here's just two examples. And one thing I want to address, which is maybe the elephant in the room, is I keep saying the word alcohol. And you might be thinking in your head, isn't alcohol like liquor, like the thing that people drink in alcoholic beverages at the age of 21? Yes. That is a generalized word though. In fact, what is in an alcoholic beverage in order to make it alcoholic is actually ethanol. So a 2-carbon chain with an alcohol on it is ethanol, and ethanol is actually what makes alcoholic beverages alcoholic. So if you see something that's like 40% alcohol by volume, like a bottle of vodka or something like that, that is talking about 40% ethanol. Ethanol is a type of alcohol. So we've actually kind of overgeneralized the term alcohol. Ethanol is just one type of alcohol. There's tons of different types of alcohol. For example, methanol. So look at these two structures really quick. Really similar, right? Ethanol, methanol, the difference is one carbon. Well, ethanol is in like a glass of wine, Methanol makes you go blind. So too much consumption of methanol will actually cause you to go blind. So this is one of the things I love about organic chemistry is just these subtle nuances of structure create a whole difference in our bodies and how we process them. And that's what we're going to be getting into with food. Another one you've probably heard about is rubbing alcohol, right? So like that's like if you like get a cut or something, you can put rubbing alcohol in it. Rubbing alcohol looks like this. Boom, 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 boom. So a little bit different than the other two. So if you were to name this, you would start off with prop, right? Because there's 3 carbons in the chain. You would say anol, because you see this OH hanging off of it. And then when you did your numbering, you'd go 1, 2, 3. And then if you go the other way, 1, 2, 3. Notice either way it's on the 2. So the final name of this would be 2-propanol. So that is like the fancy name for rubbing alcohol. So just by doing these couple of, oh, hi. Can you not? Just by doing these couple of examples, hopefully you can see that this is going to be really similar to all the work that we've already done. We're just adding the anol ending to it. So why don't we go ahead and try naming these 2 that we've got right here. So this first one, the main thing that I'm seeing right away is the cyclo, right? So I'm going to start off by naming this guy by writing down cyclo. Once I've got my cyclo, then I'm going to see how many are in the cyclo. And it looks like I've got 1, 2, 3, 4, 5 carbons. So I'm going to say cyclopent. So I've got cyclopent, and then, oh, look, I see this OH. I know that this OH is an alcohol. And if there's an alcohol, I need the anol ending. So I'm going to say cyclopentanol, done. That's the name of this guy. Okay. This guy, again, you just start off with how many carbons? 1, 2, 3, 4. So there's 4 in the longest chain, so I'm going to say bute. And I see an alcohol, so I'm going to say anol. But notice on this one, I've got 2 of them. So just like we did with double bonds and triple bonds, if you've got more than one of them, you're going to add that prefix. And if in this case there's 2, I'm going to add di. So I'm going to say, watch how I do this, buta, di, all. So if you're adding di or tri, you just say all instead of anol. So the di kind of takes the place of the an. I know it's weird. And then when you do your numbering, 1, 2, 3, 4, count the other way. 1, 2, 3, 4. It's on the 2 or 3 or the 2 and 3. So the final name of this guy is going to be 2,3-butadiol. I want to show you really quick what this guy would look like in the structural format, just to kind of connect all of these dots together. So you do the bute, which is the 4 carbons. And then on 2 and 3, so 2 and 3, there is the OH. So there's the alcohol. And then you would add your hydrogens to ensure that each carbon has 4 bonds. So you can almost think of the alcohol as like a branch, kind of, except for there's not a carbon on it. So it's just an alcohol hanging off of that main structure. Are you going to leave? He's purring. I don't think we're leaving. So now let's try drawing them. All right, so let's try 2-propanol. So the first thing I do here is I see prop, so I'm going to start with 3 carbons, 1, 2, 3. And then I see anol, which means there's an alcohol. But where do I put it? Where do I put it? Oh, on the 2, which is going to be right here in the middle. So I'm going to go ahead and move this down a bit. So on the middle carbon, I'm going to draw my OH. Done. If I did this structurally, I'd start off with my prop. And on the middle one, on the second one, I would do my alcohol. That's it. Butanol. All right, so I'm going to start with bute, which is 4. 1, 2, 3, 4. I've got an anol, which is my alcohol. And notice there's not a number on here. So remember, if there's not a number, it's always going to be on the first one. So if it's ever on number 1, we just kind of negate the 1. So you can draw it here. And notice how I drew a line. This is a very common mistake. Because if you just drew it like this, for example, you're basically destroying the carbon here, and you're destroying the bond to the OH. So you do need to draw a line out to the OH so you still have your 1, 2, 3, 4 carbons. You also could have done this to make sure you've got your 1, 2, 3, 4 carbons. Or if you did this structurally, 1, 2, 3, 4 carbons, and then just put the OH on either end of the structure. All right, last one, 1, 2, 3, pentatriol. So 1, 2, 3, 4, 5. So start with your 5 carbons. And then it looks like on the 1, the 2, and the 3, I have an alcohol. That's that all ending. And I knew there was 3 of them because of the tri prefix. And again, just to bring this all together, if I drew this structurally, pent, 5 carbons, and on the 1, 2, 3, I would draw my alcohols. It doesn't matter if they're pointing up or if they're pointing down. That doesn't have any effect on the final structure of the name. And that's basically it. So that's how you're going to draw and name alcohols on our organic structures.